the area of Tamil Nadu. They are holding about 30% of the world market. Nice. They are the 1/7 the area of Tamil Nadu. They are holding the 30% of the world market. Not even US is holding only about 8% of the IC manufacturing, but Taiwan is holding about. The trick was, you know Xerox. I can go to the Xerox shop and take a Xerox. It costs me 1 rupee. If you go to Sivagasi and take it as the same print, if you take about 1,000 copies, how much it will charge you? In the Xerox company, 1,000 rupees. I mean, they may reduce to charge this. But if you do the same 1,000 copies at Sivagasi, it costs me maybe 100 rupees. But the problem with Sivagasi is what? They take bulk volume. They didn't take 1 or 2 copies. Xerox company could do 1 or 2. The mistake was, this is what happened. The Taiwanese companies say that you give me circuit, I will put it inside the IC and give it to you. But only thing is you have to order how much? Well, so what we do here was, in the companies, those days, I work, actually I did those things. We put everything on the breadboard first, then make a circuit and test everything on the circuit solder. This we call as a prototyping. This is called prototyping. We do all the thing in prototyping, then everything is tested. Then we give the IC for the company, they will manufacture the chip and give it to me. Only one chip. Previously I had how many chips? No, they made a single chip and give it to me. But one problem here is what? One problem is, once a chip comes to you, that's all you have to use it. If you want to make any changes, you have to throw it away. This IC, we call it as a ASIC, application specific IC. Application specific IC. This is what they manufacture. You can use it only once. If something is wrong, you have to throw it away. Nothing can be done. These things are all same. 7408, 7432. These are all called ASICs. The problem was, this affects both the people. It affects me also because I cannot do ASIC. The reason was, initially my designs were only about 5 gates, 10 gates. When I start doing about 100 gates, how many IC I use? I cannot do the thing, solder everything. So I stopped doing it. At the same time, I cannot make my manufacture IC because they ask the order of minimum 1 lakh quantities. Same thing they will do it. In Sivagasi, if you go think, you know what they do it actually? They have a peak period, they have a lean period. When they don't have a work sometime, they leave the machine idle, what lot? They lose the money. So what they do there is, the Sivagasi people are very intelligent. When there's a lean period, they will print the 2016 calendars, everything. Okay, they will print that all those date sheet, everything they keep it. They don't keep it ideal. But when you say that, when you give an order, they will print only your card and then they paste this and give it to you. They keep it ready, so they don't leave the ideal. Same way, what these IC companies did was, they had manufactured the IC, but only one thing they did. They manufactured the IC. We think that they had all the gates. They had lot of gates. They put a lot of gates inside the IC. But unfortunately, you have a piece. Same IC. It is the same IC, but only thing is, nothing is connected inside. Nothing is connected inside. They say that this IC you can buy it in market, which is free. Anybody can say free, cheap rate. Because no connection is there, they could make 10 lakh pieces and distribute it. Everybody could go to market and buy it for 100 rupees. You did not buy 1 lakh pieces. But they said you connect as you wish. How do you connect? How do you connect? I cannot open the IC. It is a very beautiful thing. What they have done is they made a connection with lot of fuses. They connected with all the things with the fuses. All the gates are connected. They said that whichever connection you don't want, you cut the fuse. The cutting the fuse is called, what's the name they given? It's called unfortunately this is also called everything they see, they had a one concept man. Anything is changeable is called anything is easy to change, I call as a there's a big confusion. We have also hardware, firmware and software. What is the difference between firmware and software? What is hard, what is firm, what is soft? And to whom I am going to be soft? To whom I am going to be hard? See, when I am calling hardware, I am a hard person. Means that I am hard with the students. I am soft with the students. As a hardware, I am a parent. Hey, this guy is too rigid with the kids. He is soft with the kids. See, this hard, soft, and firm is very, very relative term. I can use it anywhere. So, hardware means to whom I am going to be hard. What is software? To whom I am going to be soft? Do you know that? Do you know what is the other? We don't see everywhere we have confusion. We know bias. Actually, we misquote what bias wrong. We never use the word called wrong. Same way we have CMOS. We never use CMOS RAM. Say also we have flash. It's called flash. You know flash chip. Flash. How do you end with flash? EEPROM. Flash EEPROM. We don't use it. We call only flash. Same way. So the same way here. What is hardware? What is firmware? What is software? Do you know that? Have you ever thought of it? What is hardware? He is hard for what? Why do you call it a hardware? Why do you call somebody as a software? Why do you call something as a hardware? That's a trick. So we better have to understand that. Okay, we'll analyze that. Same way here, this is called as ASIC. And this is called programming the circuit. Actually you are not programming, what are you doing? You are only connection. It's actually there's a very nice word is there. It's not called programming, it is called configuring is a right word. But unfortunately the person who invented this has given a name called programming. We start calling that device as a PLD. Programmable logic devices. Programmable logic devices. They are nothing but, I have two type of IC. One IC is I fix everything and give it to you. Other one, I don't fix it. In this PLD, there are three devices came. One is called PAL, PLA, and we will discuss all these things. What is these things? In another session of thing. But suddenly what happened? Now I got a invention to development. I got a huge IC. I got from SSI to MSI to VLSI. I got a lot of space. Then they started putting more transistors. What people did was, they put more PLD inside the IC. I have PLD, 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 PLD. Then they called that as a CPLD, complex PLD. But if something is complex, something has to be easy, but they call it as a simple. So what they call these as a simple PLD. See, like actually, if you see any movie come, they say Vishwarupam comes. When they release a Vishwarupam, it was not called Vishwarupam 1. They never thought Vishwarupam 2 will come. Home Alone. So you will never see Home Alone. So first thing will come only as a time. Only when you are successful, they call another one. So you will say day, actually the market does not have SPLD. They had only PLD. When the CPLD came, they want to group them, they call it as a SPLD. SPLD came very late. And then what happened? There's a new development came, they could put more number of CPLDs inside. Okay, they have become too much. They call it as a FPG. Today all the things are gone. Today, see, like SSI, MSI, LSI and VLSI. Today nobody uses SSI or LSI. We use only VLSI. Same way here, we stop using this thing today. Nobody uses this. We use only today. ASIC. Next one is. The problem is FPGA is very simple. I have to make only connections. They make it. But who will draw the circuit? Who will draw the? Somebody will draw it. No? I can draw with the 10 gates or 20 gates. We have 1000 gates. And how the timing and everything, what is the propagation delay of each one, everything has become too complex. And that time only there is a company who wanted to have the calculator they want to make. They want to make a calculator. And they were a Japanese company called Visicom. They want to make a calculator. The calculator was very unfortunately on so big, with so many ICs and everything. They approached a company in US, which was just started. There was a very nice company called Fairchild. You have heard of it? Fairchild. They are the pioneers in IC manufacturing, and that company had some good employees. That employees have said, hey, this project is not doing as my expectation. So I have a lot of energy. So why don't we start a company? They have started a company in 1967, and that company was started doing a small ICs. They were manufacturing. That time what happened? This Visicom contacted them. Hey, we want to do a lot of additional functions and multiplication, subtraction, everything. Can you make so many ICs? But unfortunately, as usual, it's a small company. They did not have the manpower to make so many ICs. But I also don't want to lose the order. Because I started a company, somebody is giving the order. Will I say that no? So we had come out to a compromise. Hey, at the compromise they found a method. I can do something very nicely. I cannot make such a big IC and no facility available what you want. But I do one thing. I have all these components kept inside my IC. Inside my IC. But only thing is, I can do only operation at a time. I can do how many operation? I cannot do two operation. I can do only. For example, we all famously we know this. A, B. A bar, B, A bar, sorry. B bar. So here, A, B bar, plus A bar. Nothing but a XOR gate. So you would have seen in the college, using breadboard, you would have got a AND gate, everything. When you give a signal, you would have got an output. The thing that everybody takes a propagation delay of few microseconds, you get the result in few microseconds. The same thing when I implement it inside the FPGA or PLD. I do one thing, all the gates are there, whatever gates I want, I connect them. But now they come to a new conclusion. What is this case? Hey, there's one thing here. I have this block is having an AND gates. This block is having OR gates. This block is having a NOT gate. And there is a block having a adder. This block is having a subtractor. Okay. Then this block is having some latch. I have everything. But the beauty is, even though I have everything, all of them are connected to what? Only one set of wires. That is called, we call as a bus. So in the class you take, even though we have so many people, only one can talk. Not anybody can talk. Same way, they said that, hey, let this guy come out. Let it go to, hey, I want to do the AND function. Let us say here. I divide this function A bar B plus B bar A as A bar first. I will do first what? What I will calculate? A bar. And store it at one latch. Then I will calculate B. Then I will do this function here. Then put it on another latch. Then what I will do? I will calculate B bar. Then I calculate A and B bar and put it on another latch. Then I will do the A bar B plus. See, I am doing the same thing. How I am doing now? But beauty is, after completing one step, I store the result in. If I don't store it on latch, what will happen? That operation is become waste. So I split the operation into so many steps. I started doing it everything. I start doing everything. There is a change in the technology. Instead of doing in a parallel way, I am doing it in a sequential way. This sequentially, what we are doing is called program. Okay, and here I have somebody here. I tell you what to do, and this guy will control this. We will discuss in depth of this later. Now I am giving a top level view. This guy is called microprocessor. I do the same thing, A bar B plus B bar A. What you did it on the, first I did it through discrete. After discrete I did it through the ASIC. Then ASIC I went into the PLD. Then same thing I started doing it in the microprocessor, where everything is in sequential. I do spend a lot of time in flowing. How I am doing, how I am splitting, the problem is this guy does not know. It is your job. It is whose job? Our job to split the operation into one by one and give it here, I need not have to know anything about it. See here, to do this operation, I need not know about what? Circuits, I know anything. I should know first I should give what? Then I should calculate for B. Then I should calculate B for B. See, the problem is, I have a big task. I have a big task of y is equal to A B bar plus B A bar. I should know that how to split the big task into. That is all. One thing is understand. I need not have to know about what? Electronics. I need not have to know about electronics. I have to know only what? I should know a big task to small task. This is what essentially called programming. You just think of a minute. What is programming? You'll be very surprised. Go back to your school, your second standard or third standard. Your teacher taught you multiplication, addition, 2-digit addition. Your teacher taught you 74 plus 21. Okay. When the teacher is teaching you 2-digit addition, what the teacher assumes? You know? Single-digit addition. And also, she made you to do the 2-digit addition. She didn't do that. So, think of it. Still you don't forget. Still you remember. You can take 2-digit addition. Who taught you the method? Your teacher in the school. You never remember. She taught you a procedure. What procedure are? Add the first digit, put the result. Then add the second digit, you put the result. But unfortunately, another teacher will give you next sum. 74 plus 46. What the kid will do? What the kid will do actually? Very simple. 4 plus 6, 10. 74 plus 11. Miss? That's what the answer will be. Like we know it. So, the English teacher teach me no. Then English teacher teach me. Every kid in the school will tell you this as a now. Nobody will teach you no. The kid will tell you only now. Then the teacher will teach you, hey, no, this is a science in K. You will say no. Same way here, this is what we do it. Then the teacher will tell you no, kid. Because 6 plus 4 is 10. If anything above 10 comes, you have to take the carry forward here. You put only value. Then 7 plus 4, 11, you put all here. See, she taught you some procedure. The teacher taught you some procedure. You remember the procedure. Understand one thing. What the teacher assumed is, you know single digit addition. And what she made you to do is, you don't know what? 2-digit. Understand? You don't know 2-digit addition, but you know single digit addition. The teacher made you to do the but by giving a procedure. They are giving a procedure. That procedure is called program. Why it is called program? Why it is called program? Because program word came before that. You would have heard called dance program. You heard a word called sports program, musical program. You say 9 o'clock, chief guest arrives. 9:30, chief guest light the lamp. 9:50, so and so girl do the Balajee, everything. Etc. Any event which is done sequentially is called program. Here also same thing. If I add these two first, if you do these two second, what happens? You will not get the result. So in any of this problem solving, the steps has to be followed sequentially. It is a scheduled event, one by one. Anything scheduled it is called programming. The beauty is here. What I am doing here is like this. I told you so many steps, A bar, B and everything. What I am doing here is, I tell him first, A, by giving something called 10. Now let us. You have to be Anish. What timing?
No, sir.
Another 1 minute.
It's your wish, sir. When you
I told you, don't give me the thing to wait. I told you already. It's a big problem.
Karthik sir has given us time till 1:30.
Okay, we'll have another 30 minutes. We'll try to close this.
We started at 10:30, so.
Yeah, we started at 10:30, so we'll have a thing. So the trick is here. I have a small circuit. I have some ICs, so 4 ICs. I want to connect from this IC, this outputs to, and give the circuit to my soldering person because I don't know soldering. I gave it to the technician. The technician did the connection and gave it to me. I tested. I got a result. Then what happened? I asked him, hey, what do you do? Change the other circuit. I changed the circuit this way. And and gave it to him. He did the connection. So I was doing so many changes. Every time I give it to the soldering person, then the soldering person found out, hey, this person is doing same circuit, different time. Then he said, sir, do one thing, sir. Don't every time confuse me. Do one thing. All your circuits you already know that. You give it to me the circuits. You give me the circuits in hand. 1, 2, 3, 4, 5. You tell me, hey, solder the circuit 5. I will solder the circuit 5. You tell me 2. I will do the. You don't tell. You don't give me the circuit. You already given me the circuit. You give it to me. I will do the. So you tell me only the number. You tell me the number. I will give you the circuit. This is what the agreement between me and the soldering person. Now, the same thing we did here. What thing was? You know that a simple device called latch. Latch is having an input, D, output is Q. We have something called latch enable. When latch enable is 1, input goes to the output. When this is 0, block. Okay, this is very simple. And we always using 8. We never use 3 or 5 or 7 or 8. Why we use only 8? Any idea? Everywhere we use only 8. Even if you today, even if your processor is 64-bit processor, what is your RAM size? How much RAM you have in your laptop? 2 gigabyte. You never say. Your pen drive is 8 gigabyte. We use only one term in measurement. We use the quantity use only bytes. Somehow along the digital, 8 is a famous number, magic number. Why is a magic number? Why 8 is a magic number? Why 8 bit is 1 byte? You know, C language does not support other than 8 bit. The minimum thing is 8 bit.
Conversion to X and
Not like that.
byte is easy to
The
convert.
reason was very funny. The reason was when they was first attached, it's the happiest moment, am I right? The whole electronics world and everybody was dying with the circuits and everything, always boring with so many soldering and everything. That time an Intel company. This is what the project from ECEIDChennai of calculator. I told you the friend. This company was called Intel. It's actually they registered a name called Integrated Electronics. The registration of company said, oh, sorry. At least somebody registered for integration of Integrated Electronics. Then they have shortlisted called Intel. This was the game Andy Grove and Gordon Moore. 2 people have started the company in 1967. They were predominantly manufacturing RAM and ROM. Only in 1968, when the PCCom entered with them out to the calculator, they invented the microprocessor, which is about 4004. It's the first processor. It happened in 1969. It came to market in 1970. But unfortunately, during the process, the company PCCom, in Japan company, they got bankrupt. Did not have money to pay to Intel. Intel is the one who did the service for PCCom. It is not Intel has not put the money and designed the product. Intel has did only the service company. They did the service for who? PCCom. PCCom is a product company, calculator. But PCCom has given the money to Intel. They are not able to pay. By the time they come bankrupt. So Intel said, you don't have to give the money. That is it. Let's say intelligence happened with whom you are. With Andy Grove and Gordon Moore. That's a very intelligent guy. The Andy Grove. What he did, he said, you don't give me the money. Forget. But give me all the rights. Give me all the. He found out that this is going to change the. That same thing happened to Microsoft. You know that Bill Gates. What happened? Somebody was having the small code has written a small operating system using assembly code. And IBM was searching for the operating system. IBM went to the company called CP Bottom. That was a very famous operating system. That when the IBM executive went for the CP Bottom CEO, that guy was on a flight. So the IBM people have got annoyed. Hey, we came such a senior people and your company CEO is not even giving a respect. So they came back. That time who was sitting in the office? Bill Gates. So they have said, hey, we will raise a contract with you. Then Bill Gates suddenly knew that somebody was having a office. So Bill Gates did not write even a single line of code for the MS-DOS. It was with somebody else. He bought that thing for how much? $10,000. Today, what is the worth of Bill Gates? That's it. This is all, you have to know the history, you will enjoy that. I enjoy these things. For me, so watching movies, I read all these things and enjoy it. So, which one is it? What happened? This guy bought the rights from Intel, sorry, BC from. Then they become their own processor. Then they did a small change. This is making 4004, they made it 808. They make it slightly faster. And to do some changes, they made 8088. Then they made 8080. Wow. The market was flooded with only. You should see that 1980 stages. Very college, everywhere, people are talking about only. Today you see that now, everywhere people are talking about Arduino and Raspberry Pi, every exhibition, every college project, robotics, everywhere. Same thing in those days you should see every shop. People are using only 80. If you take today, all this. Yes. Yeah, exactly. Yeah, we are coming exactly closing to the thing. Yes.
Next time also dedicated to my
Okay.
So this one is just
Then we carry on. Let's fight. Then carry on. Then fight. I told you, you have to be very clear. With me, I told you very clear. I only know agree or anything. Because somebody is listening to me after. I did so many years of experiment. I cannot talk this to college students. Nobody is listening at all. I thought at least somebody is listening to me, I'm just talking. That's okay. Just say see, that doesn't happen to only musicians. If somebody, if you're a good singer, somebody is sitting and listening to you, what level? You'll never stop singing. That's the thing. Somebody takes a mood, somebody enjoys something. I enjoy this, somebody is listening, so I'm talking. So you have to be a call. You have to be very, very clear.
I told you after microcontrollers is something more.
Which one?
After microcontrollers,
No, I'm not. I can stop. I can give it back to them. No. Now I'm going to start here. I will make sure that how I told you today exactly at the end of the session, maybe another 30 minutes, how C is a hardware. I will prove that C is a hardware. With that, I stop. We have microcontroller next session.
that's what
That's right. So to discuss about microcontroller, we have to discuss about something else. That we will do it later. There is some prerequisite for discussing about it. So what happened was, that's the reason, no, I just told you because it's 8. This 8 is a magic number. So what they did was very clear. You know that I have a circuit. My sorting person said, he's very intelligent, he's a skilled labor. Sir, you are doing the same circuit repeatedly. I give you a small advice. I give you only one circuit. I give you only, don't depend on me. Don't depend on me anymore. Do one thing. I will connect with everything switches. I will connect everything with the switches. You want this switch, and you want, one means 8 switches. Always everything is on 8. You want this switch and this switch, what will happen? This output goes to this input. Same way, there is an input here, there is an input here. Like I say a latch. A latch is having an input and an output. This is an input, this is an output. And you have an adder. If you have an adder means you have an input and you have an output. So every block has connected the switches. You see, he said, sir, even 11 o'clock, 12 o'clock, night time, you don't depend on me. I may not be there in the lab, but you have a circuit, whichever switch you wanted to have, you control it. Then our man was very intelligent. See, the skilled people are given an idea. I'm an intelligent guy. I thought that, hey, when that guy could able to think that much, why not I think slightly better? I removed the manual switch with the electronic switch called, what is this? A tri-state buffer. A tri-state is nothing but a switch. I replaced all this thing here. Now beauty is, for me, still better. Now you see here. Now I'm still better. I did not have to on the switch. If I make this is a 8. See, this is a tri-state now. Tri-state is nothing but a. So have 8 switches. If all the enablers are connected, so give 5 volt, whatever, all the switches are going to be on. By changing this gate to 5 volt, I am connecting all the 8 switches. Then I thought, still better, see that for this operation, X operation, I have to connect these switches now. What they have done, I designed a logic here. I designed a